So, good morning, everybody. Myself, Acharya Vishvendra, and today I'm going to discuss a worksheet on Maxwell's speed distribution of molecules. Let's begin with the worksheet. So, the first question is that a gas has n molecules having speeds v1, v2 up to vn. The first question is average speed is. So, average speed is a summation of speeds divided by n, which is also called the arithmetic mean. Next is RMS speed is, so you take the square root, square the independent velocities divided by m, so that gives you VRMS. Next is find average speed if V1 is equal to V, V2 is equal to 2V and Vn is equal to Nv. So substituting the values in this expression, we have an expression like this. Taking V as common, we have 1 plus 2 plus so on up to n by n. Now this thing is summation of first and natural numbers, which is n into n plus 1 by 2. So from where we get v into n plus 1 by 2. Next is, let me to write it over here that 1 plus 2 plus so on up to n. This is n plus 1 by 2. Next is VRMS, so just square the terms. We will get an expression like this. And here we need to use the sum of a square of first and natural numbers, which is equal to n into n plus 1 into 2n plus 1 by 6. So after substituting the values here, we get this thing as VRMS. Next is we need to find V average by VRMS. So the ratio comes out to be 3 by 2, n plus 1 by 2, n plus 1. So we can relate to it. Next is for an ideal gas in a container, VRMS is equal to, so this formula was derived by Maxwell himself. So VRMS is equal to root 3 RT by capital M, where R is gas constant, M is molecular mass in gram. This is also equal to root 3 kT by M, where kT is Boltzmann constant and M is atomic mass in AMU. And it is also equal to root 3P by D. P is the pressure and D is the density. Next is VRMS versus T graph. It is a parabola because it is proportional to root T. Then if we draw graph between VRMS and root T, that will be a straight line. The graph between VRMS and M, that will be rectangular hyperbola. The graph between VRMS and 1 by root M, that will again be a straight line. If we draw graph between VRMS and 1 by M, so root 1 by M will be root x. So we can say that VRM is proportional to root x. So the graph will be a parabola. Next is we are being given three different graphs and VRM is proportional to root T by M. So T is constant over here. So VRMS is proportional to root 1 by M. And as we can see from the graph that V1 is greater than V2 greater than V3. That means M1 less than M2 less than M3. Next question is which gas is heaviest? So we can see that M3 is greatest, so gas M3 will be heaviest. Next is which gas is lightest? So we can see that M1 will be lightest over here. Next is we are being given a graph between VRMS and M. So we can say that VRMS is proportional to root T. So corresponding to the greatest V, we have the greatest T. So as we can see over here that greatest V is V1. So the greatest temperature will be T1 greater than T2 greater than T3. That will be the order. Next is which graph corresponds to highest temperature? So it is first graph. And then which graph corresponds to lowest temperature? So it is the third graph.